welcome to Melak Online Tutorial. Now before us is this exponential equation, and it says x raised to the power of x equals 3 raised to the power of x plus 9. And we have to find the value of x. So how do we solve this? Now first of all, let's do it this way. Let's resolve the left hand side. And according to the law of indices, that says x raised to the power of n plus m. Resolving this will give us a raised to the power of what? N times a raised to the power of what? M. So applying this rule to the left hand side, here we have x raised to the power of x, then equals 3 raised to the power of x times 3 raised to the power of what? 9. Now let's divide both sides by 3 raised to the power of x, and what we are doing so is to bring together the variables with the exponent x. So we have 3 raised to the power of x, 3 raised to the power of x. So this will eliminate this. So at this point, so let us recall that when we have a raised to the power of n all over b raised to the power of n, as long as they are having the same exponent, this can also be written as a all over a all over b all raised to the power of what? N. So at this point we can now say x all over 3 all raised to the power of x then equals 3 raised to the power of what? 9. Okay, so at this point I can actually employ manipulation here, mathematical manipulation. Then my answer will actually give me 9. And how? I can see this 3 here to be 9 all over 3, because 9 all over 3 will give us 3. So at this point you can see some sort of similarity here. Then x this 9. Okay, but however I won't do that. So here you have 3 raised to the power of what? I want to use the Olympiad W function. Okay, now let us apply the ln, that's the natural logarithm, to both sides of the equation. So here we have ln x all over 3 all raised to the power of x equals ln 3 raised to the power of what? 9. And according to the law of logarithm, let's see, if you have log a raised to the power of n, it is the same thing as saying n log a. Applying that rule here, we're going to have x ln x all over 3 then equals ln 3 raised to the power of what? 9. Now for us to apply the Olympiad W function, we need to have an exponential expression like this, and we apply the Olympiad W function. This will give us what? A. Okay, now we get to see that here we have the ln x all over 3. Okay, now how do we get this term for x here? Now what we need to do is divide both sides by 3. Now by dividing both sides by 3, now here we can now have x all over 3 times ln x all over 3 then equals ln 3 raised to the power of raised to the power of 9 all over what? 3. Okay, now take note, some of you might be asking questions here. Now look at this. If you have a times b, okay, all over c, now this can either be a all over c times b, or a times b all over what? C. Okay, so that's what I actually apply here. And why I did that is I needed this x to have this denominator of what? 3, and this will help us achieve this expression here. If you have x can also be written as e raised to the power of what? Ln x. Okay, now you can see that we have x all over 3 here, and here we have ln x all over 3. Okay, and it's very important that whatever base we are having here must be the same as the exponent here. Okay, now how then do we do that? Now here we have x. Our x can also be e raised to the power of what? ln x. Okay, now if we apply this rule here, it means we can raise x raised to the x all over 3, okay, which is represented as what? X. So we can raise it as what? E ln x all over 3. Okay, so by that, but before we do that, let me quickly do this. We can swap this by saying ln x all over 3 times x all over 3 then equals ln 3 raised to the power of 9 all over what? 3. Okay, so at this point now we can now apply this rule here. So here we have that ln x all over 3, then we have e, okay, ln x all over what? 3, then equals ln 3 raised to the power of 9 all over what? 3. Okay, all right, now you can see that this expression here is the same thing as the exponent. So at this point now we can now apply the lambda w function. So here we can now say w into ln x all over 3 e ln x all over 3 then equal the w into ln 3 raised to the power of what? 9 all over 3. Okay, so at this point now, take note, this will give us a. So which implies here we have ln x all over 3 then equals to w, the lambda w function, ln 3 raised to the power of 9 all over what? 3. Okay, now for us to achieve or find the value of x here, first of all, what we need to do, take note, according to this rule here, for us to get x, if we have x, we can actually have it as e raised to the power of ln x, and in the same way, if we have e raised to the power of ln x, this will also give us what? X. So which means we can actually apply e to both sides. Okay, so by applying e to both sides, we have e then ln x all over 3 then equals e raised to the power of, this is e raised to the power of ln x over 3 then e raised to the power of what? The lambda w function into ln 3 raised to the power of 9 all over what? 3. Okay, so at this point, this will eliminate this, then we are left with x all over 3 then equals e raised to the power of w into ln 3 raised to the power of 9 all over 3. Okay, so at this point, let us now multiply both sides by 3. By multiplying both sides by 3, you have 3 times here, then this is 3, then this will eliminate this. So our x will now be 3 e w into what? ln 3 raised to the power of 9 then all over 3. Okay, so and if you actually plug in this into the lambda w function calculator, the whole of this will give us what? 9. Therefore x equals what? 9. Final answer. If you